Today we're having a slightly different program. So we're gonna be 4 speakers from DTU. And the idea was to try to link the topics of our research and our talks under some umbrella and try to compare the types of problems we're trying to solve and the methods we use each and how they relate to each other. The umbrella we came up with, which is very broad, is learning and optimization methods for decision making under uncertainty, specifically in energy systems. So I'm going to try to connect the different talks that you're going to hear later today. And then in the afternoon, we're going to have a conclusion, and I would like you to, in groups, try to think of the different methods we are going to present and try to come up with a topic that is related to your research and compare how those different methods could be applied to your problem and which one might be more relevant for your problem. So, decision making under uncertainty, in the, I guess, the broadest sense I could come up with, is choosing an optimal action when the outcomes, for example, the rewards or the losses you derive from this action, are not fully known or cannot fully be predicted. So this means that typically you're trying to find some decisions based on some available information that is not the whole information about your problem. So to do that, what we try to do in general is to develop different types of models that are going to map this available information to the optimal decisions, right? Of course, there's a lot of different types of models that are used to do this. Some are predictive models. So based on some available information, we are trying to predict the value of the unknown parameters that we need to make our decisions. So there's a lot of different models, regression models, clustering, some more advanced neural network. For example, you could use this kind of models to predict what the wind power will be tomorrow or the day ahead prices. So those are predictive models. The other type of model that we can use are decision-making models or prescriptive models that, based on the available information that you have at the time, or also the predictions that you've derived, are trying to prescribe what are the best decisions to make. So those types of models, they can include some type of multi-stage stochastic or robust optimization, some more simple decision rules, or some neural networks that are used to learn the best decisions. So this is overall the framework when you're trying to make decisions under uncertainty. Once you've made those decisions, typically in the future, you'll see the realization of the uncertainty and the uncertain parameters you had, and you'll know the reward or the losses associated with your decisions. So this is more or less the pipeline, right? When you're trying to make decisions under uncertainty. You need to develop those models, apply them to your available information, and then you observe your losses once the uncertainty is realized. So what are the challenges when you try to solve this type of problems, and how does our research try to tackle these different challenges? So the first one, and that's going to be the first presentation or case study by Jalal and myself, is how do we utilize all the available information and all the contextual information that we might have to develop, to make decisions with this contextual information. So how do we make better informed decision based on the context and the available information that we have? Once we've done that, a second challenge is, okay, we've gotten decisions based on some available information, But how can we guarantee that the decisions we've made are gonna give us good rewards, right? So how can we guarantee the quality of our decisions? And this is what Lesia is going to talk about. How can we derive analytically some guarantees on our decisions based on the predictions that we have available? And then the third talk, which is going to be by Spiros this afternoon, is going to be more advanced about how we improve those prediction and decision-making models to make them more computationally efficient using some advanced machine learning methodologies. So what can we do to improve those decision-making models using learning? So we're going to tackle, you're going to see these three topics this morning and this afternoon. And after that, we're going to have some discussions about